Good afternoon, this is Mr. Precella, and today we're going to be discussing some applications of using algebra techniques that you know. Today we're going to be looking at some formulas and working with formulas, so we may as well get right to it. And problem number 1 says an individual's basal metabolic rate is the minimum number of calories required to sustain life when the individual is at rest. It can be thought of as the number of calories burned by an individual who sleeps all day. Okay. The formula for basal metabolic rate for a man is given by R equals 61 plus 6.27W plus 12.H minus 6.2A. That formula is worthless without knowing what all those variables stand for. In the formula, R is calories per day, W is the weight in pounds, H is the height in inches. So if they give it to you in feet, you're going to have to multiply by 12 to get it in inches, and A is the age in years. Well, I think I better write that formula down and we can get started on this. So I guess you've seen me long enough. Let me stop that and let me write this down. R equals 61 plus 6.27W plus 12.8H minus 6.2A. So I'm just writing down the formula. I wonder what's going on here. It's not showing. Oh, there it is. Okay. So I've written it down. Now let's reread read more of the problem and see what are all these variables. We're told R is calories. W is the weight in pounds. H is height in inches. And A is age in years. So I've written that down. Now let's see, we're going to be told some numbers to plug in. Okay. A person weighs 172 pounds, so I'll write that out beside the W, is 5 feet 3 inches. Well, we're going to need that, and it's 35 years old. I'm going to write 35. But that height is what's a little problematic because we need it in inches, not 5 feet 3 inches. So I'm going to convert that height to inches. There's 12 inches in each foot, so 5 times 12 plus 3. So that's going to be 63 inches that we're working with. Now we need to find the person's basal metabolic rate. That's the calories, R. So I'm going to plug those numbers in for W, H, and A. And I'll use my calculator then to get R. But here it is. R equals 61 plus 6.27W. So that is 172 pounds. I'll put parentheses for times. Plus 12.8 times H, well, we're using 63 inches, minus 6.2 times A, that's 35. So let me punch this into my calculator. I'll move the calculator right here, turn it on. Okay, so 61 plus 6.27, I'm just going to say times. If you want to use the parentheses like I've written for times, that's fine. Plus 1, no, not 128, it's 12.8 times 63, and then a minus 6.2 times 35. Read through it, make sure I didn't enter a number here. And 1728.84. I wonder if they want us to enter that as a decimal or round it to 1729. Let's see. The process is round to the nearest integer. So instead of 728.84, that would round up to a 1729. 1729. Check it. Okay. Now part B says solve this formula for W. So that means get the W by itself. So that was part A. So that means, it says solve for W. That means isolate the W. So let me go ahead and write the formula again. 61 plus 6.27W plus 12.8H minus 6.2A. Well, we're solving for W, so we want this W by itself. The first thing I'll do is move every term that doesn't have a W over. I'm trying to get the W by itself. So that would be subtract 61, subtract 12.8, and add 6.2. So we'd have R minus 61, then another minus 12.8H, and then add 6.2A equals 6.27W. Notice I'm isolating the W on the right because this first number here is positive. If it had been negative, I think if I was solving for A here, I would have moved this over there and moved the R over here. But on this one, I'm trying to solve for W. All that's left to do is divide both sides by 6.27. So there it is, solve for W. So we're going to have to type this in. So let me get over here. And let's see, how are we going to type this in? Well, you click on the box, and there you see little tools. I'm going to go ahead and write the fraction bar. And now, capital R minus 61 minus 12.8 lowercase h plus 6.2a all divided by 6.27. I'm going to do a little research later and see, is this formula actually correct, or are they just making up numbers for this, or making up a formula? Because if it does, a 96-year-old who's weighing about 74 pounds, I'm going to try to figure out, is that a normal weight, or how much should a 96-year-old be weighing? But that's irrelevant. So I'll say check to y'all. I'll check this answer. Okay. So let's see. What's the next one? Okay, problem 2. The number of calories required each day by a moderately active female who wants to maintain her weight is estimated by this formula. So I'm going to go ahead and write down this formula. K equals 1013.98 plus 6.7W, no, 75W, plus 7.24H, minus 7.24A. So 1013.98 plus 6.75W plus 7.24H minus 7.24A. So W is the weight in pounds, H is the height in inches, just like on the previous one, A is the age in years. So at this point, I've just written down the problem I did on the other one. And now, let's figure out what numbers we're plugging in. The person is a moderately active 32-year-old woman who weighs 163 pounds and is 5 feet 10 inches. 5 feet 10 inches. But we got to put this in inches, so I'll just go 5 times 12 plus 10. Okay, so I'm calculating that height for a 5 foot 10 inch woman. It'd be 60 inches plus 10, 70 inches. So find the number of calories she requires each day in order to maintain her weight. So like the other one, we're going to plug these numbers in. Get over here. Plugging in the numbers. K equals 1013.98 plus 6.75 times 163 plus 7.24 times 70 minus 7.24 times 32. So I'll have to punch that into my calculator again. Let me see. My calculator. I need to make this a little bigger. Throw that out. So it's 1013.98 plus 6.75 times 163 plus 7.24 times 70 minus 7.24 times 32. Okay, so we're getting 2389.35. Let's see how we told around this. Person requires approximately, rounding to the nearest integers. So would I leave this as 89 or do I need to make it as a 90? Well, since the digit after the 89 is smaller than 5, if it's 4 or smaller, you just drop it. It's called truncating. If the digit after the 89 had been a 5 or bigger, you'd round up. So we'll make it just 2389 And now, oh, they want us to solve for A. So let me write down the formula. Here's part B. So here. So K equals 1013.98 plus 6.75W plus 7.24H minus 7.24A. So I'm solving for A. Since this number here is negative, I'm going to go ahead and set it up like this. I'm going to move the negative 7.24a over to the right by adding 7.24a, in which case then I'll need to subtract the k. So we have, moving this over, 7.24a. The reason I'm moving that over is I don't like having that negative there. We don't want the number in the bottom of a fraction to be negative. Okay, that's why I left the w over here on the right, because it was already positive. So we have 7.24a equals 1013.98 plus 6.75w plus 7.24h, and then a minus k. And what do we need to do now to get the a by itself? Well, we're going to just, the opposite of multiplying by 7.24 is to divide. So divide both sides by 7.24. Okay? So we'll type all of this in as our answer. Here, type in fraction bar. 1013.98 plus 6.75 W plus 7.24 H minus a capital K. Since they're using a capital K up here, don't change it to a lowercase k. I'm not sure what would happen. It might count it wrong. All divided by 7.24. Okay. Any questions on that? Are y'all staying caught up? Okay. Let's see. Next question. Oh, let me move this out of the way. One formula for projecting human birth weight is given by P, probably for projected weight, equals 9.337 dA, that means D times A, minus 299, for P is the projected birth weight in grams. Projected birth weight. In case you're wondering what I'm writing, I'm just writing down. Oh, let me move this up a little. Yeah, I'm just writing down the problem at this point. D is the diameter of the head in centimeters. So I'll just say diameter. And let me see, are they giving us centimeters? Yeah, okay. And A is the circumference of the abdomen in centimeters. So I did the lazy way. I did it right. Circumference of the abdomen. I just wrote abdomen. Okay. Now let's see. We need to figure out, use the formula to estimate the birth weight of a baby which has a head diameter of 7.6 centimeters. So that's the diameter of the head. So D is 7.6. And an abdominal circumference of 28.7. So the 28.7 is A. So now we're going to plug in P equals 9.337. I'm going to say times D, 7.6, times A, and then minus 299. Let me see. Bring up my calculator. Actually, we'll keep that showing. So I'm punching in 9.337 times D, 7.6, times A, 28.7, subtract 299. Now this should be the weight of a newborn, so you shouldn't expect a negative number. Okay, so 1737.586. 1737.58644. I suspect they want an integer. Here. So, yeah, round to the nearest gram. So, let's see. Should I leave this as a 37 or make it a 38? Well, I think I got to make it a 38, don't I? Because the digit after the 37 is a 5. So 1738. Let's see. There. Oh, and now let's see what this says. Solve the formula for A, and this one you don't have to type it in. It's multiple choice for you. Okay. So let me write the formula down again, and we're going to isolate A. Okay. So this is the second part of the problem. Here's the first part. So P equals 9.337 dA minus 299. We're going to try to isolate A. Isn't that? Let me look again and make sure that's what it says to isolate or to solve for. Yep, solve for A. Well, we'll start off by moving the 299 over here, moving the term that doesn't have an A in it. So we have P plus 299 equals 9.337 dA. And now to get the A by itself, this is being, the A is being multiplied by 9.337 D. So to undo multiplication, we divide. So 9.337 D. So there, the A is by itself. Y'all write it neater. A equals P plus 299 divided by 9.337 D. If we're going to be typing it in, that's what you would type in. Let's see. Oh, don't let the fact that they put the A equals. It's the same thing. Which one is P plus 299? Is it A? Yeah, it is A. You got to look really closely on that back here. Let me see if I can move this out of the way. There. Okay, just flying right on along. Clear up this. Move this out. Young's rule for determining the size of. Let's see. Hold on. Yeah, that looks better. Young's rule for determining the size of a child's medicine dosage is given by C equals A times D divided by A plus 12. At this point, hopefully you're getting the pattern. I'm writing down the form. Ooh, I need to move this up, don't I? Writing down the formula. Now let's write down what all these variables are. A is the child's age. A is the age. And D is the usual adult dosage. Usual adult dosage. And then they give you a good warning. Do not apply this formula without consulting a physician. Okay, the usual dosage of a medication is 270 milligrams. Find the dosage for a 7-year-old child. Okay. So at this point, I've written out the formula and what the A and D stand for. Let's look back at the problem and see what is the value of A and what's the value of D that we're given. Well, the age of the child is 7. And the usual dosage for an adult, 270 milligrams. So we're going to plug a 7 in for A and a 270 for D. So here we go. C equals, I didn't have my spiral notebook today. That's why I'm writing it on this tablet here. So C equals A times D. That would be 7 times 270 divided by A plus 12. Now the 7 plus 12, we can go ahead and do that in our head and say 19. So we have 7 times 270, 7 times 270, it's 1890 divided by 19, 99.4736 ... Let me see. Probably it's going to ask just to round to the nearest integer. Yeah, it says round to the nearest milligram, and that's your answers. So how am I going to round this 99.47? Do I leave it as a 99 or round it up to 100? Well, since the digit after the 99 is a 4, we leave it as a 99. Right? Again, don't start using that formula on your own. And next it says, solve the formula for D. So let me write this down, and we're going to try to get the D by itself. C equals AD divided by A plus 12. We're solving for D. So that means get the D by itself. Okay. Well, the first thing we should do here is get rid of this fraction. And the way you can get rid of the fraction is to multiply both sides by what? Well, the A plus 12. If we multiply both sides by A plus 12, we're no longer going to have a fraction over here. Over here we have A plus 12. So A plus 12 times C, that's going to be AC plus 12C equals A times D. Notice how I distributed the C. And now what do I do to get the D by itself? Well, this is A times D. The operation that undoes multiplication is division. So we will divide both sides by A. So we have AC plus 12C all divided by A. So let me see. You know what? I distributed the C, but they didn't do that. They just left it as C times A plus 12. Okay, how? Okay, see, they didn't distribute that. They just left it as C times A plus 12 all over A. See how they left it? And if this were a problem where you were typing in the answer, I would have sure typed this in. Okay? And it would have been correct, but since they didn't distribute it, this is the one we've got to use. So which answer choice was that? Let's see. Answer C. Move that. Click check answer. Okay. Oh, now this looks like a messy formula. Look at this. Using the formula L equals 0.000, L equals, I may as well just start writing it out. 0.000169, then that's a D to the 2.27 power all over H, for L is the proper length in feet of the letters painted on the pavement. D is the distance in feet from the car to the lettering, and H is the height in feet of the eye above the road. Find the height L when, and they just tell you, H is 4 feet, D is 200 feet, plug this in for L. Plug this in and find L. So, okay. Let me lift this up. So we're going to plug a 4 in for H and a 200 for D. So L 0.000169. D, that means times D, all divided by H, 4. Get this calculator up. Make sure it's all cleared out. So 0.4 oh, you know what? Let me go 0 point. 0, 0, 0, 1, 6, 9 times 200. So the top number is that divided by, oh wait, let me clear that out. I'll see what I did wrong. It should be d to the 2.27 power. And right here, see, I didn't even see that 2.27 when I was plugging in. Okay, so there should be, let me put this in red. 2.27. D to the 2.27 power. So let me clear this. 0.000169 times 200 raised to the 2.27 power. Did y'all see that key? This is how most calculators, not most, but a lot of them, denote exponent 2.27. So now, okay, that's the top number, divided by 4. So we're getting a 7.0658. How are we told to round it? Probably just to integer. Oh no, round to the nearest tenth of a foot. Tenth of a foot would be 1 digit after the decimal point. So are we going to leave it as 7.0 or make it 7.1? Well, since the digit after the 0 is a 6, we're going to round it up to 7.1. Okay? Let's see. Problem number 6. Okay, well, there's a formula from geometry that we sort of assume y'all know in this course. It's called the Pythagorean Theorem. Pythagorean Theorem. The Pythagorean Theorem deals with a right triangle. That's a triangle that has one leg, that meets in 90 degrees. It's a right triangle. This little mark here means it's a 90-degree angle. When you're working with a right triangle, the two sides that form the 90-degree angle are called legs, and the side opposite the 90-degree angle, the longest side, that's called the hypotenuse. I won't bother writing out the word leg. I assume most of y'all can spell leg, L-E-G. The Pythagorean theorem says if you call the two legs A and B and the hypotenuse C, then A squared plus B squared is equal to C squared. We're going to start working some examples involving this Pythagorean theorem. Okay, let's see this first one right here. How long is a guy wire reaching from the top of a 21-foot pole to a point on the ground 9 feet from the pole? So this is problem 6. So can y'all sort of picture a right triangle here? There's a pole that's 21 feet long. So we have a pole 21 feet. And this pole is a guy wire there. And the wire reaches from the top of the 21-foot pole to a point on the ground 9 feet from the pole. Let's see what you see. I can see what I'm drawing. So we want to know if this were a wire. So there's a 21-foot pole, and then there's a wire going from the top of the pole to the ground 9 feet away. So y'all see the right triangle here? Right there. So A is 9, B is 21. Oops, it's supposed to be FT, for feet. We're trying to find C. So A squared plus B squared is C squared. So 9 squared plus 21 squared is C squared. Let's punch in 9 squared plus 21 squared. So 522. That's, oh, gotta do this. There. Let me move my calculator out of the way of the work. Oh, sorry. So A squared plus B squared is C squared. 9 squared plus 21 squared is C squared. So 9 squared plus 21 squared is 522. Now that's the value of C squared. How am I going to figure out C? Well, I have to take the square root of 522. Okay? If these had been smaller numbers, it'd be much more obvious why I'm taking the square root. If it had said C squared equals 25, well, what number can you square to get a 25? So, square root. So, what's the square root? On this calculator, the square root key is here in yellow. So, I'll go second square root, 522. So 22.8473. How are we told to write this? Or to round it? Oh, wait. It says type an exact answer using radicals as needed. Okay. So square root of 522. Okay? It didn't want you to put the decimal number in. It wanted you to... Okay? So that's called the Pythagorean Theorem, and there's going to be... Oh, wait. Then we're not finished with the problem. Now it wants you to enter this rounded to the nearest thousandth. So round to the nearest thousandth, how many digits is that? Tenths, hundredths, thousandths. So that's 7. When it says round to the nearest thousandth, that means the same thing as saying round to 3 decimal places. So am I going to leave this as a 7 or make it an 8? Well, I'm going to leave it as a 7 because the digit after the 7 is a 3. So let's type that in. 22.847 feet. Okay? I think the next one's another Pythagorean theorem problem. Let's see. A stereo receiver is in a corner of an 11 by 10 foot room. Okay. Speaker wire will run under a rug diagonally to a speaker in the far corner. A 5 feet of slack is required on each end, how long a piece of wire should be purchased? Okay, so problem number 7. We have a room that's 11 feet by 10 feet. So I'm drawing a room 11 feet by 10 feet. So all I've done is drawn a rectangle, 11 feet by 10 feet. Well, we're going to, we want to find the length of that diagonal. So a stereo receiver is in a corner. Speaker wire will run under a rug diagonally. So, like this. There. To the far corner. So, this is the speaker wire. We need 5 feet of slack on each end. So what we're going to do is find this red length using the Pythagorean Theorem and then add 5 feet and 5 feet. So whatever this answer is, we'll add the 10 feet because of the 5 extra here. So we're going to find this length using the Pythagorean Theorem, and then we'll add the 5 extra feet on each end. Okay? So we have a squared plus b squared c squared. So 11 squared plus 10 squared is c squared. Where's my calculator? Let me pull that up here. Come right here. Let me clear that off. So 11 squared, 121, plus 10 squared, 100, so 221. So we have c squared is 221. To find c, we take the square root of 221. Second square root, 221. 14.8666. Let's see, how are we told to round this? To the nearest foot. Okay? So we have C is 14.866 ... Well, we'll round that to 15 feet. But the answer isn't 15 feet. Remember, they said you need 5 extra feet on either end. Okay? So the 15 feet is what just goes under the rug. But you got to have 5 feet over here and 5 feet over here. So I'm just going to add that 10 extra feet to get 25 feet. The wire should be 25 feet long. And again, why am I saying 25 rather than 15? Because it says 5 feet of slack is required on each end. Okay. Oh, here's a little plumbing problem using the Pythagorean theorem. Plumbers use the Pythagorean theorem to calculate pipe length. If a pipe is to be offset, as shown in this figure, the travel or length of the pipe is calculated using the lengths of the advance and the offset. So y'all see we have a right triangle right here. I'm tracing along it. Right there. Find the travel if the offset is 16.75 inches. So we're going to have this side with 16.75 inches, and the advanced side, this leg here, 12.25 inches. So let me go ahead and start what I'm about to do, or show you in a moment. I'm drawing the right triangle. The offset is 16.75 inches. The advance is 12.25 inches. And we're going to try to find that travel. So once again, we're given A and B. We've got to figure out C. Okay? Let's find C. So we'll go A squared plus B squared C squared. So 12.25 squared plus 16.75 squared equals C squared. Let's get our calculator out for that. 12.25. Well, this is how you enter an exponent other than square, but if you're just entering a square, this little thing right here does it fastest. Plus 16.75 square, 430.625. That's C squared. So to get C, we take the square root of that. Square root of 430.625. Wondering how do they want us to round it? Round to the nearest thousand. Okay. So the square root of 430.625. Oops. Is, now rounding to the nearest thousandth means 3 digits after the decimal point. So we have 20.75150 blah blah blah. Nearest thousandths, tenths, hundredths, thousandth. Do I leave it as a 1 or round it up to a 2? Well, I've rounded up to a 2 because the digit after the 1 is a 5. So 20.752. Let me see. Adding to the nearest thousand. 20.752. Check it. Okay. Y'all getting the hang of this quadratic formula? Not quadratic formula, Pythagorean Theorem. Oh, let's see. So this is just a straightforward, here's A, here's B, find C. Well, heck, how did this one get in here? By that I mean, should have been, that probably should have been, so I'm drawing the triangle. A, B, C. Oh, both of those are 12. Okay. So these two sides are equal. Find C. Okay. Oh, pretty much what we've been doing. A squared plus B squared equals C squared. Well, A squared, I can do that in my head. 144 plus 144. That's 288. Well, I'll go ahead and patch it in. 12 squared plus 12 squared. 288. So let's see. Oh, this pen's coming down. 280. C squared, 288. C C would be the square root of 288. And now, I wonder, we need the decimal. I think it says to give both, but can we simplify that square root of 288? Remember how we did that? Is there a perfect square that divides into 288? Does 4 divide into 288? Yeah. Let's see if there's a bigger one. Going through those perfect squares. 4, 9. So 4 and 9 both go into it. 16 does also. What's the biggest one? 25 sure doesn't. Since 4 and 9 both divide evenly, what do y'all think? Does 36 divide evenly? Yeah. But we could simplify square root of 8, so there's some bigger number. Oh, well, duh, I feel so stupid. What's the biggest perfect square that divides evenly into 288? How about 144? So we can simplify the square root of 288 by thinking of it as the square root of 144 times 2. So this would simplify to 12 square root of 2. That'll be the exact value they want us to punch in. 12 square root of 2. Instructions here said to type the exact answer first. 12 square root of 2. And now, given a rounded value, approximate value, round to 3 decimal places. Well, if you want to type in 12 square root of 2 for the decimal point value, that's fine. I think it might be easier just to type this in, square root of 288. And that'll get you the same thing as typing 12 square root of 2. So however you want to do it. Okay. And now how did it say to round this thing? To 3 decimal places. So 1, 2, 3. Are we going to leave that as a 0 or make it into a 1? Make it a 1? Because the digit after the 0 is a 5. So 16.971. Okay. Problem number 10. Oh. See, applications of this algebra. We've discussed complex numbers at this point. Complex numbers are used to describe current, I, voltage, E, and impedance, Z. These 3 quantities are related by the equation E equals IZ. Given 2 of these quantities, solve the equation E equals IZ for the missing variable. Well, they want us to find E. Okay? E is I times Z. This is problem number 10. We're told E equals I times Z. Okay. I'm just writing that formula. E equals IZ. I'm now going to replace the I with 6 plus 7I and the Z with 5 plus 3I. So it's just 6 plus 7I times 5 plus 3I. So we've already multiplied complex numbers earlier. Well, to multiply this semester. To multiply complex numbers, you FOIL it out And then what do you have to do when you get an I squared? You replace the I squared with -1. So we're FOILing it out, replacing the I squared with -1. So it would be 30 plus 18i. Is this a plus 35i? And a plus 21i squared. 7i times 3i. Now, if we replace this I squared with a -1, positive 21 times a -1, that's just going to be a -21. So 30 plus 18i plus 35i minus 21 turns out to be 30 minus 21. Is that going to give us a 9? And then 18i plus 35i, what's that going to be? Is that a 53i? Any future electrical engineers, you'll do a lot of work with complex numbers. Okay? So, I don't need this here. 9 plus 53i. Type it in the form a plus bi. 9 plus 53i. Check the answer. Oh, okay. Sorry for that brief interruption there. As you noticed, something happened. But we're back up and running just in time to say that we're finished for the day. So that's the last example I wanted to do there. So hopefully you're having a good day and you're staying caught up in the coursework. It's not a good idea to get behind because it's harder to catch up than it is to stay caught up. Okay? So this was working with some applications. So I don't know when you're going to be watching it, what the weather is, but right now here in Corpus Christi, it's been 100 degrees every day for over a week. We're in the middle of a heat wave, and it's not even summer yet. Summer starts tomorrow. But anyway, so I hope you have a good weekend, and thank you for watching. Not a good weekend, a good day, or weekend, if it's weekend when you watch. But thank you again, and good night.